Hi there, this is Dr. Matthew J. Traum from Engineer Inc. We are now nearing the end of the series of lectures that I've put together to show you guys how to set up, calibrate, and ultimately collect data from the PASCO stress strain apparatus. What I've done here is set up my screen in sort of a split view so you can see the PASCO capstone data collection application here, and then what the experiment looks like as I'm collecting the data here on the right. Now remember, I've already put a sample coupon in, which is made of aluminum, and I've pre-loaded it with about 5 newtons per PASCO instructions. So this is already preloaded to 5 newtons. But remember, when we did the calibration beam previously and set a curve corresponding to the bending of the entire apparatus, we only took data associated with the point after the beam had been loaded beyond 5 newtons of force. So everything will be self-consistent when we put all the data together later on as we're doing the data analysis. So I've got this guy preloaded again to 5 newtons. And what I'm going to do is change the scales so that the scales are appropriate to what I'm expecting here. So I'm going to cheat a little bit. I already sort of know the answer because I've already run one of these. So I'm going to set the force. This is aluminum. I'm going to set the force maybe to about 7 newtons. And I'm going to set the displacement not to 1/2 meter for sure, but down to about a 1/10 of a meter. There we go. Okay. Now, when I start recording, these should be 0, right? Because I zeroed them out before I stopped when I did the calibration the last time. I might have bumped the experiment. The temperature might have changed a little bit, so we might have to re-zero them, but hopefully not. So I'll start recording. Okay, almost perfect. So I'm just going to re-zero this guy by pushing the 0 button on the force sensor. He's now zeroed. And I'm now ready to collect data. So what I'm going to do is I'm going to turn the rotary to linear displacement apparatus here. I'm going to turn it clockwise, and I'm going to try to turn it as smoothly as possible. Turning it smoothly gives me a nice clean set of data, and I will turn it and you guys will see what happens. Eventually, I'm going to produce a position versus force curve here, and hopefully, if things go as planned, this coupon will fail somewhere here in the middle, and we will get all of the information we need to produce a stress strain curve and a failure point. So here we go. I'm going to try to just turn this as smoothly as possible. And I was wrong about the maximum displacement, but thankfully, oh, okay. There is our failure. So you guys can see right there where the sample coupon broke, and you guys can see in the data we have this nice smooth curve where we get continued expansion, and then all of a sudden a breaking point right there. So that is the collected data. So to pull the collected data off, I've already done it behind the scenes for the calibration, but I like to work in Microsoft Excel. So what I'm going to do is pull up a table here and collect the data off of the table and drop it into Excel. So I'm going to open up a table. Oh, there we go. In PASCO capstone, I've got to actually drag it in there, and then for the X direction I'm going to choose position, and for the Y direction I'm going to choose force. Now something interesting here, I'm actually going to stop recording data. This data is recorded parametrically, right? So all of these zeros here and all of these little negative 0.1s here, these are data that are recorded in time and are essentially useless to me because all I'm interested in is what happens when the force starts to get imposed on the sample. So what I'm going to do is I'm going to just scroll down with my mouse until I reach the data that starts to be interesting. So you can see there's a lot of time here where I was busy talking and we weren't collecting any meaningful data. Aha, here it is. Okay, so here's where the meaningful data start, right? When the force goes from 0 to some non-zero value. So I'm going to start collecting the data right here. These are very, very tiny displacements. They're essentially 0. So I'm going to start maybe from here. And then just like in any Microsoft product, I can just grab the data like this. So I'm just holding my mouse down and scrolling down, collecting the data. And what I'm looking for is the point of rupture, the point where the sample fails. Oh, there it is. So you see here, very abruptly, I go from a force of 5.3 newtons, 4.9, and then negative 4.6. So I'm going to grab that first, negative 4.6. And now I can just copy and pull up Microsoft Excel. Here's data. I mentioned that I'd cheated and I'd taken data before. So here's data from a previous run. And then I'm just going to paste the data. Whoops. There we go. Paste data from the new run in there and move up. Okay. So, and these are essentially 0. So I'm just going to type 0, 0 in there just so I don't get confused. Now let's just look and see what this looks like. So I'm going to collect all of my data points and I'm going to insert table, insert a chart. There we go. Okay, so there we go. There is not yet a stress strain curve because I haven't processed the data, but I have displacement again in meters on the x-axis, and then I have the force required to create that displacement on the y-axis. And of course, this is for aluminum. And what I want to just check is to make sure that this curve, at least topologically, looks similar to the curve that I collected in PASCO capstone here, and it does, right? So if I move this guy, whoops, if I move this guy down to 0 and I change the scale, right, I'm looking for a failure point of a little bit higher than 5, which is exactly what I achieve here, a little bit higher than 5 newtons. Okay, so it looks like I've captured the correct data. I've now got it pasted in Excel, so I can manipulate it in Excel, do any processes or functions I want to it, and move forward from there with my analysis. So from this data, I should be able to extract stress strain information for that particular aluminum sample. Now let's close this off and just look carefully here. The sample failed right at this spot. You can see it there. There's a little break in the coupon. And so now, just to wrap things up, I can take my wrench. This is my 3/8 wrench that I used before. And I can turn, remember I want to turn counterclockwise. There we go. Loosen this up a little bit and I can pull out the sample coupon, which has now been spent. And the apparatus is now ready for the next experiment. I can put another sample coupon in here. I do not have to do the recalibration with the calibration bar because that's already done. I've got that curve. I've got that data. All that I need to do is put another sample in there, preload it to about 5 newtons, the way that I showed you in the previous video, and run the experiment again. I can do that as many times as I have samples. Okay, well, so that's the end of this series of videos. Thank you for your attention, and I look forward to seeing you in the future. Bye.